So let's see the problem whether you can do it or not. The question is, you have x given by symbols x1, x2, x3, x4, x5, x6, x7 with the respective probabilities as 0.4, 0.2, 0.12, 0.08, 0.08, 1, 2, 3, 4, 5, 6, 7, 0.08 and 0.04. I guess then 1, 2, 3, 4, 5, 6, 7. So this is the sequence of symbols and the respective probabilities given. This is 0. This is 0.08. Okay, this is not 0.008. You remove this one. 0.08. Okay. The question is, first use the Shannon's binary technique. Shannon binary technique to solve for the code words and comment on the coding efficiency. Shannon's binary technique is a very old technique and it has its limitation, as we all know from the last day. The efficiency was not that much. So we will see for this example also whether it at all matches. So comment on the efficiency or the coding efficiency. Right? And for the given same numerical, solve it using Shannon Fano and compare the efficiency for this. Please do it. This is the task that I am giving it to you. I need the exact solutions for both these questions because it will be a unique solution. So it can't be multiple. Just go back, refer to the earlier days, how we have done it. For Shannon binary, we were dividing it into alpha 0, alpha 1, alpha 2, alpha 3 like that. In Shannon Fano, the process was much simpler. So try doing it. The arrangements of the probability in the decreasing order is already given to us. Okay, so we don't have to do for the first step where you have to arrange the probabilities. So I'll give you some time. Just do it. Please take some time to solve it. let's see whether you are approaching in the correct direction. I'm taking the first thing. At least tell me how you are starting with the problem. So I'm trying to find Shannon's binary. Okay, the first thing we are taking. So alpha 0, you have to take it as 0. That's where you start. So give me alpha 1. What is the value you're getting? 0.4. Okay. Alpha 2. That's correct. Alpha 3. 0.72. Alpha 4. 0.8. Okay. Alpha 5. Alpha 5. 0.88. Alpha 6. 0.96. This is where we end because we will not take the last sample. So now as you know the alpha, make sure the inequality holds. Check for the inequality. I check for the length of the four words. And you convert that decimal to binary. And remember to take the number of bits as the length of the sequence. How many number of lines? How many number of bits you have to take? Okay, can one by one, I'll just ask one by one. L naught, anyone? L naught? Good. L1, correct. L2, very good. L3, right. L4, L5, correct. L6. So now is the time for decimal to binary conversion, and accordingly take the length of the bits as per the length of the components. Many steps are there that you make for people who were absent on that day, how we are making this alpha happen? It's nothing but alpha naught plus alpha 1, or rather alpha 1 is given by 0.4 plus the alpha naught. Okay, so that's what the alpha is. Similarly, alpha 2 will be alpha 1 plus the current probability Pi. That's how we are making it. And as far as the condition of length is concerned, we have to check P of Lk if it is greater than 2 to the power minus, sk is greater than 2 to the power minus lk. So we have to find a particular value of L such that this condition satisfies. So the length that we have discussed, like L0 as 2, L1 as 3, L2 as 4, L3 as 4, L4 as 4, L5 as 4 and L6 as 5. So these are the corresponding values with respect to the corresponding probabilities for which this condition satisfies. That's why the length, this will be unknown to you. This you have to fit in one by one so that the condition satisfies. That is the idea. That's the important step. Now the last portion is where you have to make sure that alpha 0 is given by in decimal figures, which you have to convert that in binary. So in binary it will be looking something like 0, 0, 0. But since L0 is 2, so we will go till this point. So your first code should look something like a 0, 0. So your alpha 1, which we had 0.4 in decimal figures, this if you convert that to binary, how do you convert that? We also did that also, 0.4 multiplied by 2. So that will be 0.8. We take the 0 out. Again 0.8 multiplied by 2. It's 1.6. We take the 1 out. Then 0.6 into 2. We'll take 1.2. We'll take 1 out. Then 0.2 multiplied by 2. It's 0.4. We'll take 0 out. We can go ahead, but we won't go for it because 0.4, the length is maximum to 3. So you have 0, 1, 1. So your binary representation is 0, 1, 1, 0 and dot dot dot, in which you only have to take the first 3, which in this case code is 0, 1. Like that for all the other codes you have to go on doing. So if you are finished with it, please tell me the complete code. These 2 I have done. Okay, let me form a table. Okay, let me form a table, then it will be easier. So I'll form a table here. So you have symbols. You have the probabilities. Symbols are maybe x1, x2, x3, x4. If you are done with binary, go to Shannon Fano. Okay, don't wait. x5, I'm doing it for people who are absent on that day also. So I'm a little bit detailed in this case, x6 and x7. The probabilities were 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.08 and 0.04. Okay, so first code will be 0, 0. Second one we have found out as 0, 1, 1. Can anyone give me 0.12 and its corresponding code word? 1001. Anyone agrees or anyone having different values? Anyone having any different answer to 2.2? That is, 0.12. Sorry, 0.1. For x3, 0.12, what will be the code word? 1001. Okay, so everyone agrees to that. 1001. Good. Next one. Okay, let me check. 1011, right? So my calculation is also correct. 1011. Okay, next one. 1100. Okay. Okay, next 0.8. Everyone agrees? 1110. Should I be doing it or is it fine for you? 1110. Last one. 4101. 4101. 0, 1. So now these are the code words. Now you have to find the length of the code, which you already have done. So 2, 2, 5. What will be the answer? You only said 4 times 1 and 0. You don't have this last one. Okay. It will be like this. Okay. One additional question to it. Is it a prefix code? Just by observing. I'm not trying to do the Crafts inequality. By observing, is it a prefix code? What is a prefix code? Where any code word will not be repeated as a prefix to another code. So it satisfies, correct. So the length of the code words are like 4, 4, 4 and 4. And this is 5. Can anyone give me hx? This value is not with me. Hx 2.42. Okay. 2.42. Any units to? Do we have any unit? 8%. Please be very careful about these units and all. Okay? Everything is very important. Can we find the L average? 3.04. Can we find eta? 70? 6.7. 6.2. So this is my efficiency with respect to Shannon's binary technique. Can anyone quickly do it for Shannon Fano? Is it clear? Everyone got the idea? These are the tabulation. If you at all you are not able to finish it, at least take the tabulation. Later on you can do it on your own and you can verify. That's why. You will have to move ahead with Shannon Fano. So okay, so let's do the Shannon Fano then. Shannon Fano, the technique was you have to divide it almost into equal halves. Keep the first half as 0, second half as 1, and go dividing these segments until and unless each and every segment has only one element. Excuse me, can you shut the door? So let us arrange it. 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.04. Now there was a confusion last day regarding the selection of the partition. How do you do it? As I told you, the partition can only be done with respect to almost equivalent two portions. That's one condition. Second, you cannot disturb the decreasing order of probability. So even if some combination of probability will give you an equal distribution, you can't do that. So the only possibilities in this case, because 0.4 is so big compared to the rest, the only segment that is possible, I guess, is here, somewhere here. Although it will not be an equal, but at least that is the only possible combination, because if you add 0.4 and 0.2, it will be 0.6. What will be the total add-on for this? So that also can be, but ideally if you make this one, so you see here only it's a very good observation. Suppose I make it 0.4 and 0.2, so that is 0.6 as you said, and 0.12 to 0.08 and all whatever we add, that's coming as 0.4. Which or the other option is you take 0.4 like this and add everything to come to 0.6. Which one would you choose? I'm asking you. The idea is right here. This is first segment, this is the rest segment. The other option is this segment somewhere here. That is 0.6, this is 0.6. So the same thing is happening. But which option is better for you? Why? Because if you are taking this as a partition, when you can see the first segment is only having one element. So your division wise, you are only doing one element. So basically you substitute here, if I consider the first half to be 1, suppose I did that. So I will put 1 over here and the rest are all 0. So I don't need to do the first segment. It's already finished because it's only having one element. Clear? This was a confusion, I guess, in the last day's class, that how you are going to segregate. The other option is also a feasible option. But then what we have to do is, with that 0.4 and 0.2, you have to divide it again into two halves, ones and zeros. So that will require an extra step, and eventually we will find that the efficiency will not be the same. So this is the best possible outcome. Correct? Okay. But again, the same thing, if suppose what she's asking, like if I do it this way, 0.1, okay, that's okay. That is also condition. Yes, what she's asking, like if I do it in the second step, we are having the second half, the lower half, we are having 0.2 and 0.2. That's okay. Maybe what we can do is we'll try both. We'll experiment. Okay. First, we'll divide it with respect to 0.4 only. Then we'll divide it into two halves. We'll see what happens. So first, we'll divide it with respect to 0.4. So we'll keep this as 1, the rest as 0. The next step, this is not needed, so this is already done. So what we are going to do is we'll have this as 1, and these are all zeros. Okay. So we are dividing. So in this second step, what we are trying to do, we are dividing 0.2 and 0.12 and the rest into two halves. The upper half I am giving 1, the rest are giving 0. Again, in the third step when we are reaching, we don't have any element with 0.2, so we are left with 0.12. So 0.12 if I reach here, again, what is the addition of this 0.0808? This is 0.2. First 2 and last 3. Okay, so I'll like 0.12 and 0.08. This partitions to 0.008, sorry, 0.08, 0.08 and 0.04. Okay, let it be this way. If this is the case, then we'll put this as 1, this is as 1, this all as zeros. Okay. Then again the problem is we have to segregate into these two halves. So the next step will involve 0.12 as 1 and 0.08 as 0, 0.08, 0.04. This all will be zeros. Now this is all done because we don't have any other element. So 0.8 will be given a 1. The rest 2 will give us 0, 0. Okay. And the end result will be here 1. This will be 0. So like that it might come somewhere. Okay. So if I divide it this way, so the codes will be codes for 0.4. What we are getting? Okay, you have considered it to be 1, or rather we have considered it to be 1 to 1. It comes out to be 1. Okay. Okay, for 0.2, 011, 01. Okay. Because the partition is different. See the changes. When I did it, what I did, I actually made sure I took 0.2 and 0.12 as one half. This is this partition. When you are looking at here what we have taken only one element. But while I was taking, I took it, what I did is I took the variation out here. The partition I took it between 0.2 and 0.12 and the rest as 1. So my codes will be different. So you tell me the value. 0.2 is 0.01. Okay. 0.12, 001. 001 for 012. 0011. Okay. 0011. Then you have 0.08. The first 08. Any value? 0010. Okay. The next 0.08. 000. Please confirm. 4 zeros. 1. Okay. 5 zeros and 1. Okay. 5 zeros and 1. And 0.04. 6 zeros. You will soon find what is the problem with this. We'll do it in a different way also. Can you calculate L average? Can you calculate L average for the given probability? And the length is also given to you. Find times 0. So is it like 5 zeros should be? Okay, if you are taking it like in this case, we are not doing it simultaneously. That's what you are asking. Yes, because when we are dividing this half, basically 0.12 and 0.08 has been taken as a one group. Okay, so in this step, when you are going from this step to this, ideally there are two modules, right? So what you can do is either you can keep 1 0 and rest as zeros. Next step, you do 1 0 zeros, or you have to divide two halves here itself. So, like you have to make this as 1 0 0. Wait. I'm just doing it for our simplification, because otherwise it will be creating a lot of problem, because suddenly people will start, because here you can see at each step we are dividing only at one row, only one partition. Here it seems there are two partitions. So it might create a confusion with you. So that's why I kept it as same. So then next step we are doing it. Each and every step we are breaking it into two halves only. Here there are two segments here. So that is to avoid. L average, anyone? 2.72. 5.72. I'm getting two different answers. 2.52, which will not match with my answer. So it's up to you. It's an equal distribution of 2.52 and 2.7. Let it be. It's not important with the answer in this case. Can anyone give me h of x, which is the same for all? 2.4, okay. In both the cases, you can check the Shannon's rule that hx is less than the L average. So both the answers might be correct. You might have gone mistake. Someone has done the mistake. But whatever it is, you find the efficiency. 96%. Okay? 96%. Can we do it in this way? Just I am telling you what to do. This half is fine. 0.4, 0.2 and the rest is fine. Can you divide? Because the problem in this code, the only problem is that for probable symbols, you are sending lots of more bits. Can we reduce the number of bits to send the same information? So we want to optimize the code a little bit. So what I'm suggesting you to do is to have a partition where you will take 0.4 as the first partition, ones and all zeros. Then the next set will be, the partition will be made between taking this as one set, 0.2 and 0.12, and this as one set. Can you just do it for me? What you are getting? So this is 0.312. Sorry, 0.32. The upper half is 0.32. The lower half is 0.36. Okay. What are my question is the first half 0.4 I am making it that we have confirmed that 0.4 if we take it the number of divisions, number of steps is less. That's why we are taking it. 0.4 you take 1, the rest are zeros. Now the next step you take the partition between taking two samples of 0.2 and 0.12 and the next set is 0.8, 0.08 to 0.04 because the first half is giving you almost 0.32 whereas this one is giving you 0.36. Tell me the codes what will be. The process is the same. So just tell me the code. Then we'll compare. Oh, you did that only. Okay. So let me just have clarification. 0.4 what you're getting. Okay. So let's have the people. That's why it is called as a suboptimal coding. It is not the optimal solution. The optimal solution will come only if I use Huffman coding, where there will be one unique solution. Shannon binary? Naturally, you can see the same codes we have done. Shannon binary, we got 76 odd. Just now we did it. 76 efficiency. Shannon Fano is naturally greater than Shannon binary. But if you want to come to an optimized coding, optimal code, then naturally Huffman is the best, which we are not doing. Okay, anyone ready with the answer? He is ready. Anyone else? 0.4, talking about that second option. 0.2 and 0.12 we are taking as one segment. 0.4 as he said is 1. 0.2 0.11. Everyone agrees to that. Okay, 0.12. 0.10. 0.08. The first 08. Huh? 0010. 0011. Okay, 0011. Second 08. 0010. Third 08. 0001. Okay, and last one. So you can see the difference. The difference in making the selection will change the number of elements that you are taking. In the first case, for the same 0.04, you are sending, although it's a null bits, but you are sending almost 6 bits at a time. Whereas for this one, you are sending only 4 bits at a time. Can anyone give me the L average for this? 2.48. So my calculation is also correct. 2.48 and HX we already did. So that was 2.42. So eta, what is the value you are getting? 97.58, 97.6%, whatever it is. So basically, by the little change in the selection, you are improving the efficiency from 96% to the next. What prompted us to change? You go back to the problem once again. When we were here, what was the addition here? You took this as 0.4. Now what you suggested is 0.2 as 1. So you are partitioned with respect to keeping in mind that we have to take less amount of partition. That's what you take. So 0.2 and the addition of this whole, what was the value? This whole? It's 0.36 plus 0.12. 0.48. See, ideally, I did it because I wanted you to understand the difference. This is 0.48. Now 0.48 and 0.2, this can't be a partition because they are not equal. 0.36 and 0.32 can be a partition. But 0.48 and 0.2 cannot be a partition, although it is possible. So we can actually come with a conclusion, okay, but the conclusion might not be the accurate one. That's what I wanted to show you. We can go on taking it in a different order. Like you can also try using 0.4 and 0.2 as one partition and the rest as 0.6. You can go ahead doing that. You will find that the optimal efficiency might not be 97.6%. You understood? That is what I did. That's why I never stopped you in dividing that whole segment. You can do it, but that is not the exact one. And even while doing or solving it in your exam, please make sure that while you are dividing each and every step into different partitions, the combination of that equal probability, total summation equal probability should exist. Please keep in mind. Okay. So this is a problem that we have solved both. Now to end our note, just a 1 minute it will take, we will use the same problem and we will take a ternary Shannon Fano technique. Check this thing out, how we can do it. What is a ternary thing? We will divide the whole segment into 3 halves. So, let me do it. You tell me the solution. Okay, now you are expert in doing it. 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.04. Ternary operation demands that we have to take 3 partitions. So naturally, if you have 3 partitions, you have zeros, ones and twos. So we'll divide it in this way. We'll put this as 0, put this as 1 and put everything as 2. So we have 3 set of rules. So naturally, the rules remain the same. So in the second step, we don't need to divide because each of this upper half will have only one element. So no need. Again, within this 0.1 to 0.04, you have to divide it into 3 halves. Again, keeping in mind the 3 of them should have almost equal probability. So, maybe what we can do is 0.12 and 0.08 we will club here and we will keep the other half as 0. This way 0.08, 0.08 and 0.04. So, your 0.12 will be 1. This will be 0. This will be 1 and this whole will be 0.12 plus, correct? Okay, so you are asking like 0.12 and you make this as partition. This one as a partition. Okay. For the time being, let us divide it this way. Maybe we will test it also, what he is suggesting. So, this is how it is. Again, we don't have any elements here. So, we have to divide this one. So, naturally, it should be 0, 1 and 2. So, we end our codes. So, codes will be 0.4 is 0, 0.2 is 1, 0.12, what will it be? 0.12, 2, 0, 2, 0, 0.08, 2, 1, 2, 1, second 0.8, 2, 2, 0, 0.08, third one, 2, 2, 1. And the last one, 0.04 is triple. Can anyone give me L average for this? Can anyone give me L average? 1.6. Is it not violating Shannon's theorem then? Because Shannon's theorem was L average should always be greater than H of x. Is it not violating them? What mistake we are doing? What mistake we have to, or what alteration we have to do in order to find the L average? What was L average? It was all taken with respect to binary bits, zeros and ones. But here there are 3. So your final outcome should look something like h of x, which is 2.42. That's okay. But this 1.6, sorry, I'm right here. 2.42 is what we have already found. So 1.6 is what troubling us. So this should be multiplied by 1.585. Why? Because you have log to the base. This is 3 symbols. It was log m. Now the symbol h of x, which is maximum value, it is log of m, where m is the total number of symbols present. For binary sources, we were taking it 2. In this case, the source of symbols are 3, 0, 1, 2. So if you take this as 1 and you compute, it will come as 585. Now you multiply this. So now the L average, whatever you are getting, is actually greater than what your Hx is. Understood? That's the only little trick in your ternary operation. So if you go about doing it, it will come around 95% as an efficiency. But the important part is this one, ternary thing. Here you have multiple number of elements instead of log 2, instead of only log 2, we are now taking log of 3. Okay. So, is there any efficiency with respect to the code word length and all? Are we saving anything? Yes, we are. You see here, for 0.12, we were having 0, 1, 0. But here we are doing 2, 0. So basically we are saving 1 bit. Similarly, you are saving a lot of bits somewhere, but at the expense of losing out on some amount of efficiency. So that is what the Shannon-Fano technique with ternary operation is usually. You can go on increasing the number of, if there is a long sequence, you can break it into 4 halves. You can give it to 0, 1, 2, 4, 1, 2, 3, and then it will be a more than ternary. That's 3. You have to take log of 4 to the base. Like that, it will go on. Okay? So this is what is there in your syllabus till this point for your CAT.